And they only are showing up in the Teams calendar that you have access to. All right, so any questions at the start? The plan is to give you practice over these, and if you need to review anything, I'll help you practice, and then the rest of the class time will let you do the redo on exam number 3. I have a version 2, different questions, more credit for doing these because they are harder, so giving you credit for those. All right, let's see if it'll add my notes here. There we go. Yeah, okay. So looking at this first problem, adding two functions together, we have this function f of x. There's what he is. He is a 5x plus 5. And this guy, g of x, just whatever number I take, square it, and add 2 times that function. F plus g, I'll do my work over here. This is my work. And remember, if you want credit to show your work, you can either take your notes on a sheet of paper and just send me a picture up to that upload section. That's important for me to see your thinking in case you have a problem. I can help you with that later, and also perhaps give you partial credit if you got really close and just missed a sign or something. Okay, so f plus g of x means the same as whatever f of x is, add it to g of x. So what that means is f of x, 5x plus 5, gets added to, because there's the plus, whatever g of x is, 2x squared plus 2x. So what we do here, we like to put it in polynomial form where we have the highest power listed first, and there is our only power of x, x squared. So we take him and put him at the front. And let's see, how many x's do we have? We have a 5x there, plus a 2x there, so that gives us a total of 7x. And then we have just the constant 5 added to everything else. There's my solution, f plus g of x. Just take whatever f of x is and add to whatever g does to x. And then the only things that I combine, I have multiples of a 5x and a 2x. Otherwise, it's the 2x squared part of g and the constant part of f of x. Do that again here. Again, we're doing the adding of two functions. Let's just do it right over here. F of x plus g of x. Here comes f of x, 3x plus 5. Now I add g of x for x squared plus 5x. Again, there's only one constant multiplied by x squared, so I have that by itself, 4x squared. And I have a 3x here, plus another 5x over there. That becomes 8x. And then the constant 5. Don't worry about needing to do any factoring. We just put the combination together, and there's our answer. The only time that factoring is helpful is in something like the next problem. But even here, I'm only needing to evaluate f and g at particular values. Let's make a little table here just to help us out, and it'll make finding these answers so much easier. Let's calculate, given a particular x, we'll calculate f at that value and g at that value. We'll make a little table here. So x is -1, -5, 5, and 2. Let's calculate f of x at each of those. It's not too hard. -1 for an x here will give us, let's do our little calculation up here. At -1, I get -1 squared, I get 1, plus a negative 1 means a minus 1 minus 12. Gives me negative 12. So negative 12 is my f at negative 1. Let's calculate it at negative 5. Well, negative 5 squared is 25, plus negative 5 means a minus of 5, minus 12. 25 minus 5 gives me 20, minus another 12 gives me 8. And for the value of 5, for f, well, I have, again, 25, 5 squared is 25, plus a 5, minus a 12. So 30 minus 12 gives me 18. And then f at 2. I get 4, 2 squared is 4, plus 2 minus 12 gives me 6 minus 12 was negative 6. Filling this table will make our problems later, f plus g, a lot easier. Now, g is a lot easier. Just subtract 3 from each number. Well, I can do that here right away. Minus 1, minus 3, negative 4, negative 8, 2, and negative 1. Now that I have this table, f plus g of x, or f plus g at negative 1 is those two add together. Negative 12 minus 4, negative 16. F minus g at negative 5, well, 8 minus negative 8 gives me 16. F times g at the value of 5, 18 times 2 is 36. F divided by g at the value of 2 is negative 6 divided by negative 1, because f at 2 is negative 6. G at 2 is negative 1 equals 6. So when they give you specific values, I find it's usually easiest just to build this table. It gets a little, especially when I come to this part. Doing that multiply can get very hard, and I'm prone to answers, or to mistakes. These, it's not too hard to actually solve for x, but this one always comes out to be a little harder. Let's do that, because this next problem wants us to put it in the form of any number. What is the form of f plus g? Basically, I'm doing a problem like this, but for more than just the f plus the g. I'm doing it for f minus, f times, and f divided by. Well, let's do the f plus g. I'll do the work over here. F x squared minus 49 plus g, which is x minus 7. And now x squared by itself, x by itself, and a minus 49 and a minus 7 makes a total of minus 56. Otherwise, x squared and x are by itself. So x squared plus x minus, what did I say, 56. And then those two. F minus g, this is tricky. Well, not super tricky, but I have the x squared minus 49 minus, and be careful to put the g in a parenthesis so you don't get that sign wrong. Let's pull it out of the parentheses. That becomes minus x plus a 7, because I'm subtracting a negative 7. Therefore, it becomes x squared minus x, and let's see, minus 49 plus 7 becomes a minus 42. Be very careful whenever you have signs and you're subtracting g, be sure to throw that in parentheses to help you remember. So easy to mess up that sign. Now comes the hardest one, f times g. Well, f is x squared minus 49. I need to multiply that by g, x minus 7. And don't panic, just crank through the multiplying. First we multiply x, and then we multiply 7, subtracting it. Let's do the multiply by x. X cubed minus 49x. All right, that's x times all of this. Now I subtract 7 times all of this. So it becomes a minus 7 times the x squared, and a minus 7 times the negative 49. Well, that becomes a rather large number. Let's go ahead and do the 49 times 7. That's 63. 6, 4 times 7 is 28, plus 6, 34. And that's a negative 7 times a negative 49. So I am adding 343. And I have an x cubed, an x squared, x, and a constant. No need to combine anything else. If I had a couple x squareds together, I'd be adding them, but they're all different powers of x. So I'll just put them in the nice order. The order doesn't matter, but I like to put them in neatly. X cubed minus 7x squared minus 49x plus 343. And that was problem 4. Now it gets a little, well, mathematically easier, but you have to watch carefully what you're doing here to get these right. And I'm put just in the right place here. Yeah, I think that's readable. What I need to do here is first find the inside. Don't even think about that. Just figure out this part first. And then we'll figure out the next step. So let's just do g of 6. So f of g of 6 means, well, function g, feeding it the value of 6, this is g of 6. Well, g of 6 is 9, so this becomes f of 9. Now, f of 9 is, the value of x is 9, f gives us a 9 when his input is 9. So therefore f of 9 is 9. I don't even worry about finding whatever this represents. I might examine the numbers and see that it's a polynomial. That doesn't matter. I just go by the table. G of f of 0 is g of, well, f of 0 is, giving an x, f gives me a 6. So that's g of 6. And g of 6 gives me a 9. F of 5, well, don't worry that I have two f's there. Just figure out what this is and feed it to whatever that is. So f of 5 is, and I have a 5, I get a 7. Now f of 7 becomes 1. G of 4 is, well, let's see here. G of 4 will be 4. There's my 5. Now, G of 5 becomes 0. So from the table, always work very much like in your regular math. Figure out what's inside the parentheses first, and then build out. So we figure out what's inside the parentheses, and then solve that as I go out. That's all that the combinations are. And this is what we call the composite, f of g. Remember, this is the same as f composite g at a specific value 6. But I do like this better because it reminds me, figure out what's inside of there, then solve it. And that's basically what we're doing here. we have to simplify F combo or F composite G of X. Remember what that means is that's F feeding to it G of X. So here is F, and his X is right here. Whatever X is, put this there in place of X. Well, let's do that. 2 times 4x squared plus 3x. That's what used to be x here, right? And all I do is multiply by 2 and add 3 to it. Okay. Now we just multiply out, and if there's anything to simplify, we'll combine the similar powers of x. Well, it looks like that's 8x squared plus 6x. That's it of those two, but don't forget, I still have to add the 3 because here we added a 3 to whatever 2 times this was. And there's no combining similar powers of x, so there's my answer. Now we get to the inverse. Remember what we do for inverse? We turn this into a y and then solve for x in terms of y. So y equals 14x plus 4. Whatever number I take, I multiply by 14 and add 4 to it to get y. Well, solve for x. First thing I do is subtract 4. Y minus 4 equals 14x. And now divide by 14, and I'll solve for what x was. Y minus 4 divided by 14 equals x. So what this is saying is, if you give me any y, subtract 4 from it, and then divide by 14, I'll get back a value x. Well, remember, y and x just stand for any number. So I can say, if I'm given a number in place of y, if I call it x, and I subtract 4 from it, and then divide by 14, I am performing a function that is the inverse of what this is doing. That's why the -1. So solve for x, and then exchange x and y. And we're going to call this a new function, f inverse. Same thing here, just a different looking function. Again, we do the y equals 1 over whatever you give me and plus 15. Well, what if I wanted to get that back? Well, I can multiply by this and divide by that. So I get x plus 15 equals 1 over y. Now, to solve for x, well, let's subtract 15 from both sides, and I have x by itself. X equals 1 over y minus 15. And thus is my inverse. If I take any number, have 1 divided by that number, or the inverse of that number, then subtract 15, I'll get an interesting number. If I happen to repeat it this, I'll get x back, because 1 over that is x plus 15. Take away 15 from that, and I'll get my x back. Thus, we call it the inverse. So the inverse function is take 1 over whatever number and subtract 15. It'll do the inverse of what that function does. There are 2 different functions. Any value of x, if I take it, do this to it, and then do this to it, I'll get x back. And there's your little practice over all of that. Any questions about this? Otherwise, the rest of the time here, I'm giving you to do the redo for exam 3. It's there in Moodle. Let me make sure it's over there in Moodle. It's your chance to do a redo of that. I'll hang around if you have any questions about it, making sure. I think there should be no password to it. And whatever your best grade is will become your exam 3 grade. And don't be embarrassed if you had trouble. Talking to the other teacher, you're not alone if you're having trouble with this. So feel free to, if you don't want to ask questions live, I am happy for you to send questions in email. But exam 3 version 2 is now open, ready for you to improve your score. So have at it. If you have questions, I will end the recording here so your questions won't be recorded.